Hello everyone, I'm Evgeny Chigurov and this is my final project report called Towards Level Story Generation. The motivation for this project came from Dr. Catalin Voss, where he said most children learn by reading, but the task of leveling books appropriately for the right reader is quite difficult for teachers. Most of the books today are targeted at a certain reading level and they remain fixed as such. As a result, they are either uninteresting to those who are way beyond that reading level or inaccessible to those who haven't reached it yet. So, could we use a little bit of AI to help the teachers out and to actually broaden the range of available books significantly to all the interested readers? When I boil the problem definition to what I actually done this semester, is it becomes selecting 108 copyright-free books from CB test dataset, which is a dataset used in one of the Facebook studies from 2017. You can see the excerpt of a portion of this dataset in the screenshot. In this particular case, Lewis Carroll Alice Adventures Underground is highlighted. There is a little bit of special characters left behind, but the gist of it is a freely available plain text story. And on the right, at the bottom right, there's a chart showing a distribution for reader kindergarten accessible sentences in one of those books in the dataset. So how did I actually go about solving this? So the step one was selecting training data for appropriate reading level. To determine the reading level of a given sentence, I used the Flash Kincaid algorithm. Then I fed into that algorithm all of the sentences from this 108 books that I got in the dataset, and I selected only those that matched the reading level or were below that. Step two, I created a fine-tuned GPT-2 transformer model. Keyword here being is fine-tuned. I was able to feed the data from step one, the data that is appropriate only for a certain reading level. I was able to feed it to the GPT-2 transformer model and basically train my model to generate reading level appropriate text in step three. And here's this small diagram showing the basic transformer architecture. In essence, it's a deep learning building block, so to speak, consisting of 6 encoders and 6 decoders that have been proven very robust and have been proven to deliver very good results when it comes to text analysis, text generation. Before I go and actually show a quick demo of what I have done, and I would like to briefly talk about challenges. So the first challenge is the training data. It could certainly be better, as there's some special characters left behind, sentences are being improperly split, no paragraph identifiers, and stories are slightly outdated. The language constructs have evolved, and so having a better training set, or training data, in my opinion, would have helped significantly in my efforts. So the second, I considered fairly minor challenge was environment setup. The deep learning transformer or transformers, which are based on the deep learning models, cost a lot of money. So to actually do a learning at scale, that is that becomes quite expensive. Then it was also slightly difficult to get the right environment. Google Cloud did not work out for me because the proper software and drivers weren't installed, but fortunately Microsoft Azure did. And finally, the biggest challenge of all was probably that the task that I set out to do is definitely not an easy problem to solve. In fact, in my opinion, it's multiple problems presented as sort of like an onion where you have to peel the layers of it to really get to the right solution. So how far was I able to get in my experimentation? So before I go into the slide, briefly talking about the results and analysis, I'd like to show you a quick demo. So in this demo, I have a Jupyter Notebook deployed to Azure Data Science VM. And here I have a model already pre-trained, and I have selected the training data to be the data from my books, from the books that I analyze, targeted at reading level 3 or below. And here, just to have a little bit of fun, I want to see what kind of text can my model generate by being fed just a single phrase called baby shark. So here we can see different sentences that the model is capable of. Baby shark has come to me for a kiss with a slight smile. That's probably my favorite out of the bunch. So next, let me just show you quickly what the real data that is being generated from the books that are contained in this data set. So here I'm picking Lucy Maud's collection of short stories. This is what the original first sentences of the book look like. I'm going to read it in the interest of time. Second is the baseline that I prepared, and the baseline essentially removes those words that are inaccessible to the readers beyond a certain level. So it's an unreadable sentence just because the words are just removed crudely. So here is some of the generation, so the text generation that I am doing. So here the sentences are very short, they are fairly well formed. However, and as I point my results right here, switching back to the slides, they don't really follow each other logically, and the meaning of the paragraph and the book and the page in the book is sort of lost in the model that I have created. So to get around that, as I suggest in my further research, should come up with better data, provide better algorithms, or potentially provide additional approaches to modeling the meaning of the paragraph and the story to the algorithm. And that is all I have.